Why are not sharing your screen on Teams? Is that
I'm not trying to share it on Teams.
okay?
Yep, sorry. Okay, let's get started. So thank you for being here today. The name of the session, hopefully you're in the right room. We're going to talk about building enterprise AI apps using the Microsoft stacks and different parts of it. So just a quick moment to thank our sponsors. So Microsoft is a sponsor for helping us organize this. And then there's also a company called AppPoint that's actually been a big supporter of the technology community for a long time, really since I started working and speaking in the community about 15 years ago. And so they're sponsoring this event as well. So a big thank you for both companies to sponsoring the event today. And so a little bit about me. My name is Paul Swider. I run a company out of Boston, Massachusetts in the United States. And we focus on healthcare technology, AI and healthcare technology in healthcare. And mostly our focus is on hospitals and hospital systems. And so some of what I will show you today is based on some of the work that we've actually done over the past couple of years in building our application and enabling it for AI. So I also love to travel. I consider myself an adventure traveler, if you will. And so I include a couple of photos. I've been to over 100 countries now. And I've been to the Philippines many times. It's one of my favorite places. And so it's always an honor to come back here and speak in Manila. And so I will also thank all of you for being here, because again, this is one of my favorite places. And so it's an honor to be here. So the topic today, just real quick. So we do a bunch of community stuff as well. We are founders of the Boston Healthcare Cloud and AI community. And so essentially we focus on some of the global goals. To be specific, number 3, good health, and then number 8, which is encouraging economic growth. Okay, so the theme for this session is becoming a frontier developer, if you will. So I'm sort of testing this new term. So some of you may have noticed that Microsoft has started talking about something called the frontier firm. And so a frontier firm is essentially a company that's being forward-leading, if you will, with AI technology, including some of the latest stuff that with Microsoft Copilot, et cetera, and also in Azure and building apps, some of the stuff we'll talk today. So I took a little bit of a leap and I said, okay, if we have frontier firms, then let's talk about being a frontier developers too, and what that means to us as developers. And so this is a developer-focused session. And so like most developer-focused sessions, I like to start right away with a demo before we even go into slides. And I think what I'd like to start by showing is sort of the core to what we'll use as some of the demos and as we go through the talk, et cetera. And so what you're looking at here is a Copilot that we've built, and we've built this from the ground up, developing the Copilot ourselves. And so one of the things you'll hear me talk about during the session is I like to bring people on a tour of, like, we start with SaaS, which is essentially Microsoft Copilot Studio, et cetera. And then we talk about moving on to the PaaS level, which is platform as a service. And so for the platform as a service side, there's the Azure Agent Studio, if you will. And we'll do some demos there. And then finally, when you get to the end, there's this world where you, at the IS level, where basically you're using Microsoft for infrastructure, but you're creating your own agents through code and you're building your own Copilot. And that's essentially the purpose of the session today, is to take you through that tour, if you will, to show you quickly what you can do in Copilot Studio. We're not going to spend too much time there. There's already, presentations on that. And then we'll spend some time looking at the Azure component. And then finally, we'll come here. We'll start to look at how we can build at the IS level and build our own agents and build our own Copilot. And so what's interesting about this demo is, the demo app, if you will, is that we're familiar with the chat interface, right? All of us by now have used the various different applications. This is actually set up to integrate with operational data for hospitals that's stored in PeopleSoft on the back end. And so as we're actually executing the prompts here, what will happen is it's actually going to use RAG. I don't want to dive too much into it at this point in the demo, but essentially it's going to pull from our database server, and then it's going to format that in a special way so that it's easy to read here on the screen. And then where it gets really interesting is we've started to add a reporting layer as well, where the users of the Copilot can start to do a deep dive into the analysis of, in this case, it's a provider, Dr. Paul Swider, for the demo purposes here. And so this is the Copilot chat interface. And then when we start to look at the agent stuff, I'm going to show you how we build our compliance agent. And then we also have on a separate tab here, we call it our RVU optimization agent. And so what I really like about this presentation and this demo is this is very real world. This is our product, how we build. This is what we are talking to people about now and deploying into hospitals in the Northeast of the United States. And so I want to start with this demo because it sort of shows you where we're going to end up at the end of the demo. And so with that, now I'm going to go back to the slides and we'll start talking about some of the basics, like what is an agent? What does that mean for developers and Copilot Studio, et cetera? But this is sort of where we'll end up by the end of the session. Okay, so first we need to define what is an agent. And I've actually included two different definitions here. And if you watch enough presentations, you'll probably find that there's even more than two definitions. But I really like to boil it down to two different definitions of what an agent is. And so first is the no-code definition. And so this is the one that people are most familiar with. When you hear people talk about agents and Copilot Studio and building agents, whether it's using Microsoft Copilot Studio, OpenAI Agent Studio, Anthropic has one now. But the idea is essentially that you have an agent that makes use of a large language model and also makes use of instructions and makes use of tools as well. And probably the most obvious, I think the best example of an agent that most of us are already familiar with are the vibe coding agents. A lot of times we overlook this, but if you think about it, vibe coding was really the very first use case for an agent, okay? Now, for example, if I go out to, I'm actually going to use a couple of different code editors for this presentation, but I'm going to start with Cursor. And so if I go out to Cursor, you can see on the right-hand side of the screen, I've got the coding agent open, and what you might be able to pick up on here is there's a simple dashboard HTML page here. This is actually an interesting story. What happened was we actually got a call from a customer that was concerned that their server was susceptible to a security breach that had happened. And so they called us and they said, Paul, are our servers okay? And so long story short, what we did is we asked the AI, we basically said, hey, this is the information on our servers. Here's the security patch. Are we okay? But then at that time, I was preparing for a demo, and I thought to myself, well, gosh, I could turn this into a really quick dashboard just, using the vibe coding editor, right? And so essentially what I did is created just that. And so you can see now it's actually branded as Bank of America. And this is just because I was testing the demo again last night. I hadn't run it in some time. And so I used the Vibe code editor in Cursor, and I said, go ahead and change the brand for this security dashboard to Bank of America. But we legitimately, like, you're actually looking at the real report that I ended up sending to the chief security officer of this hospital. Of course, it was branded with their hospital name at the time, right? It wasn't branded as Bank of America. But the point I'm making here is that vibe coding and the ability to very quickly create these assets is not always about creating an app. Like, it could be a very simple thing like, hey, I've just got this new information about a security patch. Let me just quickly create a quick HTML page that I can email to the team, right? For example, and that's essentially what we did here. So now getting back to agents, if I look at Cursor, you come back, if you look in the box, and by the way, all of them work the same way now. I'm going to show you VS Code next, we're going to dive into. But in this editor, notice I can ask or I can go into agent mode. And if I'm in agent mode, essentially that's going to let it make changes to my code. It will actually run as an agent. So remember, my premise here is that Vibe coders and Vibe coding is actually the very first use case for real agent. Okay. So let's just real quick, I'm sure people have seen demos like this, but we'll do it anyway. Let's just say, update the branding to reflect Dartmouth Health. So now, as I do this, I want to remind you that an agent has knowledge, it has tools, it can perform actions. And so what you're seeing now is the knowledge is the page. So you can see here, it's actually got the SharePoint security dashboard page open. That's its knowledge. And if you follow along here, you can see it's actually doing some thinking and it's making tool calls. It's actually going behind the scenes and it's making a tool call to the Cursor IDE and making code changes. Again, just very exactly Agent 101 stuff, if you will. We have knowledge, we have an agent, and it's acting on my behalf. And in this case, it's going ahead and it's going to update the branding of this very simple HTML page. Okay. So now you can see it's updating, it's making tool calls. Now, sometimes when you're using your Vibe code editor, it will also call out to a terminal window. And it will actually run your program and test it for you. And if it finds a bug, then it will go through and it will fix the coding bug, hopefully, in most cases. And again, the purpose of this demo is to reinforce that this is exactly what we're talking about when we're talking about agents. It's the ability to have knowledge, the tools that take action on your behalf. So hopefully this will wrap up here shortly. Good, so it's done. And so, as you would expect, I don't want to spend a lot of time here, but we refreshed the window and now it's been rebranded back to the hospital branding, right? So I went from Bank of America back to hospital branding. And again, I would submit to you that Vibe code editors were the very first use case for agents, for true agentic applications, if you will. Okay, so that's an agent, okay? And again, though, I like to think of this as the no-code definition of what an agent is. And so again, an agent, it uses a large language model, it has knowledge, and it can make tool calls. And in the case of the Vibe code editor, you just saw what that looks like. But now let's look at the developer or the Vibe code definition, if you will, of what an agent is. And so what I would submit to you is that an agent is a software component that uses one or more AI models, allows you to do complex long-running tasks, and can take actions on your behalf. And so this, as we start to move along and we go from the no-code version to the developer version of how we create agents, I would submit that from a developer perspective, this definition works a little bit better for us. And the quicker we can realize that that's what we're building once we start building these agents at the IS level, that at the end of the day, we're still building software components. It's just we're treating them a little bit differently. They're going to behave a little bit differently, and they're using some updated technology, like the large language models, et cetera. So job, tools, and tasks. Okay, so now let's start this journey. So how many people are familiar with the concept of SaaS, PaaS, and IaaS? Like just by a show of hands. Just a couple. Well, no, more people are raising their hands now. Okay, good. So about half the room. So let's just quickly talk about the difference here then. So SaaS is essentially software as a service. That's the most common one, right? We've probably all heard of that. That's, I would say 90% of startups, especially pre this new AI boom, were SaaS applications. And so essentially SaaS is, me as a business owner, I create an application, I publish it, and then I sell it to you, right? And you pay me a subscription and you use my platform. And if you stop paying your bill, then you don't have that software anymore, right? It goes away. That's the way SaaS works. And then as we go down, I like to think about it, as you go down the stack, there's this next level of PaaS, which is platform as a service. And so essentially platform as a service is you're using something like Microsoft Azure and some services of Azure to build your application on, okay? And so it's a little bit different conceptually, because when you build the application, you're not using stuff at this higher end SaaS level. You're using Azure services, things like the agent framework, Azure Foundry, for example. Another thing worth noting is that you can have a mix of things. So you can build apps that have a SaaS component, but they also have a PaaS component, meaning they're using platform services, but you build and deploy them as software as a service is what the acronym stands for. SaaS is software as a service, and PaaS is platform as a service. And then finally, the last one, IaaS, and we'll dive into all three of these and what it means from an agent perspective. With IaaS, it's infrastructure as a service. And so what that means is you're using the infrastructure of Azure, but you are taking complete ownership for all of the code. You're building it yourself. You don't have a dependency necessarily on Azure. You don't have a dependency on some of the SaaS components of Copilot Studio, et cetera. So for example, if you wanted to build Cursor, if you are the team that builds the vibe coding at agent for Cursor, you're going to do that at the IS level, right? You're going to sit down, you're going to use Rust or whatever the language of your choice is, C+, and you're going to essentially build out your agent at the code level. And I like to use the phrase, you own your own agent at that point, right? Like if you're building it at the IaaS level, a good litmus test for is it IaaS, is you should be able to be agnostic, meaning you can take it and you can move it from Azure to on-prem. You can run it on-prem on your own cloud. You could go, if for some reason you need to use another partner hyperscaler's cloud, then you should be able to take that agent and pick it up and move it to that cloud, or pick it up and move it to on-prem. And that's essentially what IaaS is, okay? And so the Copilot that I showed you in the beginning are the one that for the hospitals, that's built using IaaS, but we also consume some PaaS services from Microsoft, which I'll talk about those services as well. So let's start at the beginning with SaaS, so software as a service. So this is the most common one, and I'm sure the one that folks have already heard about, I think, and that is Microsoft Copilot Studio. And so Microsoft Copilot Studio is probably the easiest way that you can get started creating powerful agents today. And by the way, depending, if you're looking at SaaS, PaaS, IaaS, they all have trade-offs. And it's worth noting that at the SaaS level with Copilot Studio, you can do a lot. Like I would submit a lot of organizations will only need Copilot Studio. They'll build their own agents in Copilot Studio. They'll connect them to Azure services. They'll connect them to backend databases, et cetera. They'll have subscriptions that they're paying for Microsoft as part of the corporate subscription plan. And that's a great world, right? And I would submit that actually many of the companies in this room will probably fit that model. And by the way, I'm a big believer of keeping it simple. Like if you can do that and you have the licenses and your company supports it, by all means, Copilot Studio is a very, very powerful tool to allow you to build these agents. And the good news is it's one of the easiest as well. And so I put together the agent that you're looking at here. Well, let me start from the beginning. So if I click on agents, this is one I put together some time ago, last winter, I think it was. I did a demo. It's basically what I did is I built a snowboarding guide. So I grew up in Vermont in the northeast of the US, and I love to snowboard. I still like to snowboard to this day. And so what I did is I put together a quick agent that will basically suggest where I should go snowboarding. And so remember, agents have knowledge, they have tools, and they can perform actions on your behalf. In this very simple agent, I connected it to, for knowledge, I pointed it to a couple of websites that give local snow reports. So the knowledge is it knows what the snow conditions are on the mountains. And I don't actually have any actions set up for this Copilot Studio demo, if you will. But if you watch here, I'll say where should I snowboard this weekend? And you'll see what it will do is it will use its knowledge base. It will go out and it'll say, okay, this is where you should go snowboarding. And the way it's set up is it's designed to specifically look at mountains in the Northeast of the US, specifically Vermont and New Hampshire, because that's where I like to go snowboarding the most. So you'll probably notice that the results it returned are all in the context of Vermont and New Hampshire. Now, if I were going to add an action to this, notice where it says booking a hotel. This is where you might take the next step and add an action that would actually go out and take the first steps in booking the hotel, or maybe even get sophisticated enough so that it would actually book the hotel for you. And by the way, it's very doable with Copilot Studio. You may have heard the term human in the loop. I know for me, I'm not at the point yet. Again, I'm a traveler. I like to travel, so I don't even let somebody else another person book my own travel. I like to be in charge of that. And so if an agent is going to recommend a hotel for me, I want it to check with me first before it actually uses my credit card and checks, because I'm just very picky about my travel. And by the way, that's a really great example of keeping a human in the loop with your agents. You've probably heard this term and the importance of keeping a human in the loop. In this case, I'm the human and I want it to let me know before it books a hotel. So again, this is Copilot Studio. This is at the SaaS level. And very quickly, very easily, we can start to build out agents and connect them to backend systems in our organization. And really, I would say just about anything, because one of the things you'll want to know from an architecture perspective is that a lot of Copilot Studio is actually built on Dataverse and Power Platform. So for those of you that are familiar with the history of Dataverse and Power Platform, and even the integration that offers into Dynamics and the enterprise ERP, a lot of that same architecture exists underneath Copilot Studio. So what that means is, as you know, in Power Platform and Dataverse, there's Power Automate. And Power Automate, I forget how many connectors it has. It's probably in the thousands now. It's like Zapier, right? Meaning you can set up a connection to just about everything, to Workday, to Teams, to Exchange, to whatever it is that you're doing. And so these co-pilots, they can use that same exact architecture. And that's why I can confidently tell you today that you can very easily take this at the SaaS level and connect it to your corporate systems, your line of business applications, et cetera. It's because of that architecture, because a lot of it does sit on top of Dataverse. It sits on top of the connectors. And that's what makes the magic happen, if you will. Okay. So that's SaaS. So now it's Copilot Studio. This just shows a screenshot of what I already showed and demoed for you. So I got ahead of myself. There's the demo. And now remember I told you that you can have a combination of SaaS and PaaS, right? And so I think the best example of that when it comes to agents is that you can build declarative agents that they don't have to be part of Teams, but one of the common things that you'll see is the agent framework for Teams, where you're essentially building an agent at the SaaS level with Microsoft Teams, but you're consuming services like Azure services and doing this without connectors. So the biggest difference is when you're doing it at the SaaS level, you're using connectors to connect to your backend systems, et cetera. When you start creating these declarative agents, then, and again, we're moving one step down now, you're sort of in between SaaS and PaaS, because you're going to use them either in Teams or Copilot, by the way. But at the same time, you have the ability to connect into Azure services And in some cases, you can even connect to an agent framework like semantic kernel I'll talk about here in just a little bit. And so this is at the code level, more at the IaaS level, if you will. Now, one of the things that's really important to acknowledge about these declarative agents is that fundamentally they're the same, right? They have knowledge, they have skills, they can do stuff on your behalf, etc. But the other important thing to note is that it's not only teams. So if you have a product and you want to integrate it with Copilot today, not Copilot Studio, but you want to actually make it so that when users in the company they open up Microsoft 365 Copilot and there's an agents tab. Well, what you can do is you can basically wrap your existing APIs and your existing applications using a definition file, a JSON file. And basically what it does is it uses the same framework that exposes it to Teams, but exposes it to Copilot, Microsoft Copilot. So said another way, what you're looking at here makes it very easy to take your existing applications and expose them directly to Copilot. So here's a real world scenario. I showed you our Copilot. That was the demo that I did in the beginning where I showed you we can look at the doctor's report, et cetera, right? Well, being a Microsoft partner, I want to make sure that people that invest in Microsoft Copilot can also use our agents. And so the way that we do that is we actually create behind the scenes a declarative agent, it's called, which is really a JSON file that identifies where your APIs are for your agent. And then when you do that, you can deploy and it will show up into Microsoft Copilot. And by the way, if you're an inspiring entrepreneur or you want to build something for yourself, Microsoft just recently announced the marketplace for agents. So if you build these declarative agents and you can expose them through Teams and through Copilot, then you can take the next step and get them approved and get them published into the agent marketplace so that people can actually subscribe to your agent, purchase it online, and it will show up in Copilot and then go ahead and use it. So this would be not only useful for inspiring entrepreneurs or people that want to build their own stuff, but there's also a way that you can set up your own corporate agent store. So Microsoft they've extended that. So let's say you work for a larger company. What you can do is you can set up your internal agent store, and then you will start to publish internal agents, and then all of your employees will see them in the internal agent store. And so all of that magic happens at this level. It's the declarative agent level. Really, technically, if you're a developer, it's a JSON definition file that defines where are the APIs for your agent, and then it exposes them either to Teams or to Copilot itself, Microsoft 365 Copilot. So that's the big takeaways here. So that's at the SaaS level. So now we're going to move down more, and now we'll start talking about platform as a service. And I'll take questions in the end. I'm just going to go through the flow because I've got so much content to cover. So I'm going to do it very concisely, and then we can stop and ask questions about any of these levels. So when we go down to the PaaS level, the very first thing that should come to mind is the Azure AI Foundry. And so you may or may not have been exposed to this already, but this is essentially Microsoft's Azure service that allows you to deploy models, protect models, and then and do a lot more, as you'll see in just a moment. We'll actually dive into a demo of it. And so the idea is that, again, you're going down one level. So you're not doing this in Copilot Studio, but it doesn't necessarily mean it's complex, meaning like you can very quickly build agents in Azure Foundry using the Azure Agent Service without developing much code. It literally just configuring some agents, and I'll show this to you. And it's very easy to connect them. It's very easy to quickly put together agents at this level using Azure Foundry service. Now, that said, you are going a level deeper in the stack. So it can get very complex very quickly. Like this, there's a lot of magic that can happen here, as you see. For example, you can see a lot of it conceptually is the same. We create an agent. There's a new concept of a thread. The best way to understand a thread is that it helps maintain the state between your agents. Okay, so here's the best way to think about it. So when you first hear about application state, the best way to think about it is how we did things before AI. Let's say I'm creating a hello world web application. I have page 1 and I have page 2. And on page 1, I need to pass hello world to page 2. So typically that's called state. That's my application state. And typically how you would do that is you would store it in a cookie. You would say, okay, take this information, put it into a cookie, and then when I get to page 2, I'm going to go look at that same cookie, and I'm going to pull that data up onto that page, and voila, you've passed state between one page to another. That's how we've done it all along up until modern AI stuff, right? So now we have ChatGPT, we have Copilot, and the state is different because the state is semantic. It's conversational, and we need to follow that conversation and be able to pass it between chats and between agents. And so it gets a little bit more tricky. And so essentially we do that in the case of Azure service here, you'll see them use the word threads. If when you're programming and you're doing this at the vibe coding level, or you're doing it with C+ or whatever it is, whatever tool you choose, you'll hear context. You'll hear the word context used a lot. And as a matter of fact, there are even third-party services that you can subscribe to that will manage the context for all of your agents. And so, again, the best way to think about this when you see this is you're essentially managing state between your agents. You're carrying the state through the chat and through the agents, if you will. So that's threads. And then you create the agent, create the threads tie them together, and then run the agent and check the status, right? So that's sort of the 1, 2, 3 of how you do it very, very quickly. And again, it's not different from a conceptual standpoint. Like, you have instructions, and then, obviously you're making use of a large language model, and then you have tools that the agent can call, and then you track your state using threads, and then it goes and it runs and does its work. And so this is another sort of illustration of what that looks like when somebody's actually using the agents and the Copilot. It could be Copilot tied together with agents. So the person is making a request, and then number 2, the messages are sent. Well, first that's serialized. Messages are sent to the model. The model processes the input, handles any function responses, invokes the function, and then handles the chat response. There's a little bit of a loop there, and finishes the flow, if you will. So we also have, as you can imagine, if we have state, I've sort of already alluded to this, well, that implies that we can have multiple agents that are working together, right? And so part of this is that we need to, all of a sudden, so we introduce this term of orchestration. So how do we orchestrate these agents to work well together? And then part of that is managing the state for the agents, but also making sure that they're behaving well together, like they're calling the right. And at this point, I think it's helpful to start to think of these as software components. Like, we can call them agents, but now we're getting down to the PaaS and the IaaS level. And essentially, you can think of this as we've got multiple software components. We want to make sure that they responsibly execute the right software function calls, et cetera. And we want to track the state across them. Okay. And so this is multi-agent orchestration. Here's the example I like to use. This is actually a real example. This is something that Microsoft Research built in the healthcare domain. And essentially what they did, you may have heard about this on the news, but a few months ago, there was this big announcement that essentially Microsoft had achieved 95% accuracy with diagnoses and working and triaging healthcare. Like, I forget the details of exactly what the use case was. But the way they did this is they actually put together several agents, and each agent actually used different LLMs, like depending on what the agent needed to do. In some cases, it even used Grok. It used OpenAI. Like, it had access to several different large language models. And then you can see the way it set it up here is that there was a hypothesis agent, the test user agent, the challenger agent, stewardship, checklist. And then down at the bottom 3 are perhaps the most important, which is the consensus coordinator. Like, essentially what that software component or agent will do is go talk to the first 5 and make sure that everybody's in consensus. This gets back to orchestration, if you will. And then you have the gatekeeper. And so this is like the one that's responsible to go get the actual clinical information from the electronic health record, right? When you're going to do that, you have other stuff you need to think about. For example, locking records, right? If I'm going to go read from a database that has electronic health record, I might have to deal with record locking issues, et cetera. And then finally, the most important one is the judge. I always think that song, there was a song, Here Comes a Judge or something like that. But essentially what the judge does is that's your check. So the model that a lot of people are using today is your agent does some work, but then you'll call to another agent and you'll essentially say, is this right? Like, did the first agent do what it was supposed to do? And did it do it correctly? Does everything make sense? And so that would be the judge. And so essentially what you can do is you can orchestrate all of these to work together in a collaborative sense. And the end result is exponentially better than a single agent. And that's exactly how Microsoft Research was able to get to that 95%, with their, again, I forget if it was triage or diagnosis or whatever they were doing, but there was some confusion because when the news came out, it made it sound like, that there was a large language model that somehow they had put together a large language model that could do 95% accuracy in healthcare. And that's not the case. It was actually a very coordinated effort of multiple agents working together that would help them get to that 95%. Good. Okay. So let's look at the Azure AI service. That'll be our next demo. So the best way to get to the Azure Foundry is you could do ai.azure.com. And as long as you're logged in, it'll bring you to the top level of Azure Foundry. Now, a couple of things you'll want to note about the top level is that you have this concept of hubs. And then underneath hubs, you have AI projects. And it's important to acknowledge this, especially if you're working with a team or in a larger organization, because those are security boundaries. So essentially, you can say, okay, this group of people has access to this hub, and you can even define roles for them. You can say this person is an AI developer, this person is an AI user. And so that's why those are really important to acknowledge up front. And then right underneath the hub, you have the AI project. And the AI project also is a security boundary. So you can grant permissions, very specific permissions. And by the way, you actually do this in the Azure portal. So if you're familiar with using RBAC security, rules-based authentication, whatever it's called, excuse me for not remembering the acronym, you use that same exact framework to give the permissions to your Azure Hub and to your Azure AI project. So these are security boundaries. So then the next thing you do is you go to your project level. And so I'm just going to go back to this tab because I already have one open. And so you can see I'm in a project called Demo Pexco AI project. And, I know that that's connected to a hub. And so the first demo I want to show you is I put together, this one is a very simple agent. It's actually not, it's not even, there's no connections or anything like that, but it does have oh, that's the wrong one. Hold on. It has a very sophisticated instructions prompt. It's actually pages long. If you see me scrolling through this, and what this is, it's about, if I had to guess, maybe 100 to 200 lines of instruction that tell this agent how to give advice on making a hospital department operate better. Okay, so it's, again, not super complex. We go in here, we click create agent, you literally just give it a name, and then you're giving it an instruction. And we'll look at the next steps, how we connect it to knowledge, et cetera. And so then what you can do is it's very easy to start to test this thing. And so you can see here, I typed in emergency department, and now it's actually doing some thinking. It's coming back to me and it's saying, well, if you want me to be able to effectively tell you how to operate the emergency department in your hospital better, I need just a little bit more information. You may have seen this with research agents, like when you're using Microsoft Researcher or Deep Thinking, right? And some of the other ones, and it'll pause and it'll say, okay, so I'll say, okay, my hospital size is 300 beds. Hospitals are usually measured in how many patient beds they have. And I'll say the current challenge is, employee retention. And the technology infrastructure we'll say is Epic. That's one of the largest, actually the largest electronic health record. And then budget constraints, I'll say no. And our goals are increase patient satisfaction. And I'll just stop there. Typically, I might say something about employees to really make this make sense. And then, as you would guess, it's going to go away and it's going to do some thinking. And then based on the instructions I gave it, you can see it's actually coming out with a very detailed analysis of, okay, based on this department, and this is all defined in my instructions text, by the way. And by the way, I created that with a Vibe code editor. I literally did it last night for this demo. I wanted to have a new agent. So I literally just went into Cursor and I said, hey, create a sophisticated instruction set that I can use with Azure AI that will help me with operational efficiencies in hospitals. And it literally spit out like a 300-page instruction thing. I didn't even make a change to it. I copied it and I pasted it here. I tested it real quick, and that's what I'm demoing for you now. Okay. So it literally, that's the power of these tools, is we could just move 10 times faster than we could before, right? So, okay, so that's it. So, and you see how this works. So now let's take the next step. So the other thing that we can do is we can start to connect these agents. And this is where it starts to get interesting. And this ties into some of the orchestration. And so let me actually go first. I'll click on agents here. So this is an Azure Foundry. I'm clicking on agents. And you can see I've got 3 agents in here. The first one I just demoed for you is the Hospital Operational Efficiency Advisor. And then I've got 2, these come just from the standard Microsoft Learn site, very typical, very simple agents. Essentially, one of them will create a title for blog posts, and the other one will go ahead and create the actual post based on the instructions. And so the way this works is first I created the first one, which is called Title Generator. And it's fairly simple. All I've said is you're going to create a blog post based on the topic using 80s style language. So I grew up in the 80s, so I like to have fun with the 80s. So I said, use an 80s voice, 80s style voice. And then what it will do is it's connected. So if I scroll down here, so this should start looking familiar to you now. Agents, they have knowledge, they can perform actions, and they can be connected. And so what I did is I went and I added a connection, and I connected it to the outline creator. And so now these 2 agents are going to work together. The first agent's going to create the title, and it's going to pass that state to the second agent. And the second agent is going to go ahead and create the outline for the first one. And so let's go ahead and test that. And so I'll scroll back up here. I will say try in Playground. And then let's just say vibe coding. So you can see here, this is where the connection happens. So now it's connecting to that second agent. It's looking for references from the second agent. And then it went through and it created the titles. And then it stopped. It actually didn't do the second part. Hold on a second. Let me see. I think I was supposed to say create a blog post about coding. Yeah, there we go. Okay. So calls the first agent, gets the title, passes it to the second agent, and the second agent goes through and creates the outline for the blog post. So that's an example of, just to refresh your memory where we are in the presentation, we're talking about the pass level. So we're using the Azure Agent Service, which is part of Azure AI Foundry. And we're looking at building and connecting agents at the pass level. So remember, we started with Copilot Studio. Then we went down to Teams and Microsoft Copilot. Now we're down at Azure level, and we're looking at connecting them at the Azure level. And so I've showed you how we connected 2 agents. Now, the other thing to notice while you're in here is we should have a quick conversation about AI safety. One of the benefits you get when you use PaaS, when you're using the Azure Agent Service and Azure AI Foundry, is you get additional services like guardrails. So you can see I've got protect and govern section, and I can create evaluations to test the output of my agents. I can put guardrails and controls into place. I can add governance. I can set up thresholds for alerts, etc. Basically, I can add security and guardrails on top of my agents. And so that's one of the clear benefits you get when you do choose to build on a PaaS service like Microsoft, right? So you'll be able to take advantage of these guardrails and the built-in security and stuff. And then also you can do things like fine tuning. So I can go ahead and fine tune the large language model so that it more efficiently handles the questions around healthcare operations, and candidly, even more importantly, save money. A lot of people don't realize that, but one of the nicest things about fine tuning is you can actually reduce your Azure bill significantly, because you'll reduce the amount of tokens and return trips that are needed to facilitate the responses back to your Copilot or to your agents. So fine tuning is not only about producing better result sets, but it's also about saving money, which can be a big deal. Trust me, as somebody that, we build a lot of these stuff, and that's definitely a factor. And so these are all of the stuff that's built in at the PaaS level. One last thing, these are the models that are actually being used. Now, what's interesting about these models is I'm actually using them at the SaaS level with Copilot Studio. And I just showed you how I'm using them here in Azure Foundry. But also my IaaS, the Copilot that I first showed you, the code-based one, is actually connecting to these models. And so the way this happens is if I go ahead and I click on GPT-4 Mini here, that's the current model I'm using. And what you can see is that we've got a target URI, and then we've got, an API key, which obviously I'm not going to show right now. But with those two pieces of information, essentially any developer, given the right networking, obviously you can have this connected through, what are they called? The equivalent of VPNs in Azure, virtual networks. And so you want to be careful. You want to protect your keys is what I'm getting at. So the way our Copilot is set up, we've created it. There's a front end and there's a web API. And in the web API, that's the API layer that's responsible for going to the large language models. And so we put that stuff in our development environment. We put it in app settings, but the best practice is to put it in a key vault, is where that needs to be. Like, don't listen to me about app settings. That's not a good practice. Like, we just do that in our demo and dev environments. You want to put it in key vault or someplace that's a little bit more protected, obviously. Okay, so that's Azure, the agent service. Now let's go back. Okay, so now let's dive a little bit further. So I showed you how we can build agents in Azure using Foundry. I showed you how we can deploy models. I showed you how we can protect models. And now what we want to do is get down to that final level, which is IaaS. So here's the important thing. So this is real life. This is our back end. So you can see how sophisticated this is. This is actually pulling from not only systems in a hospital, but in the United States, there's been a lot of consolidation happening. So essentially now we have hospital systems. We have some hospitals that literally own over 100 other hospitals. And so we refer to these as hospital systems. And this is actually real world. It took us about 10 years to build this. We built this over 10 years with a large hospital system. And then I decided I wanted to turn it into a company. And so I took, just about 3 years ago, I took the OpenAI stuff and we put a Copilot right on top of this. And so what I'm going to show you now is how we can take it to the next level. We'll go even deeper, and how we can use IaaS and build on top of this and consume these services. And by the way, when that Copilot, that was real world. There was no, I wasn't making that demo up. When I said, go get this information about that doctor, it was literally going through this stuff here. Obviously, it's in our demo environment. It's not the production one, but it was legit going to making the same database calls, going to a smaller version of the database that's running in the dev environment. And that's what I demoed for you. So let's talk about that. So again, we put a Copilot on top of that. What does it look like? So now we're going to break out to VS Code, one of my favorite tools. And you can see VS Code very much like Cursor. We've got Copilot built into it. And what I want to point out here is that now you can start to see the next level. And this is as low in the tree as you can get. This is like, okay, I want to build my own Cursor. I want to build my own agent that I can move anywhere. I can run it on-prem. I can use Azure Foundry Local. By the way, Azure Foundry has a version called Azure Foundry Local that you can run it on-prem and do much of what you saw me do in Azure running on-prem. So that would be another use case for building at the IaaS level. Okay, so what does that look like? Well, notice here at the code level, so now you're looking at our code project, and you can see we've got a shared folder, and this is where we start to build out our agents. So you can see we've got our agent framework. There's a base class, there's a coordinator class, there are goal-driven agents, et cetera, et cetera. So I'm not going to dive into that too much. It would be silly for me to do it, because all I need to do to prove this to you is I can ask the Vibe code editor, right? I don't need to show you the code. We'll just talk to it. So I will say, okay, tell me how these agents use semantic kernel. So by the way, this is probably the biggest takeaway if you're interested in building these yourself at the IaaS level. There's something new called the Microsoft Agent Framework. And the Microsoft Agent Framework is essentially made up of a couple of things. One of those is something called semantic kernel, and there's another one called AutoGen. And these projects have been consolidated into one product. It's not really a product, it's a developer framework. It's built into .NET, and it's called the Microsoft Agent Framework. And so what we did is we started off of semantic kernel very early on. And so that's why the Vibe code editor, I said, tell me how these agents use semantic kernel, because I want to prove to you again that this is not smoke and mirrors. This is real code that's creating an agent. And again, what better way to do that than to use the Vibe code editor? And you can see it comes back and it says, well, the base class is derived from agents, and it uses some semantic kernel, and then it shows me an example of how it's used in the code, et cetera, et cetera. And so this is how you take the final step, and you will build these using the code language of your choice. So the Microsoft Agent Framework currently supports .NET, Python. I feel like there might be a third one, but those are definitely the two biggest ones. And the pattern so far has been that they release first for .NET, which you might say, well, that sounds crazy because Python is, a newer language, it's more fun and everything. But the reality is that most of the enterprises around the world still run on .NET code, right? And also, I would submit that Python is more of like a experimental developing language, right? Like you're testing stuff, you're doing research. Like a lot of the research labs use Python, et cetera. But then at the end of the day, once you have stuff that you've built in Python, you need to deploy it to the enterprise. And so a lot of times what folks will do is they'll do it in C#. That's what we've done. And so our web API is built using C#, and we consume some PaaS services, and we also consume IaaS services that we built. So for example, we've got an entire layer that connects to our backend database servers. We're out of time? Yeah, okay, cool. That's good because I'm out of stuff to talk about. So anyway, but that, I hope you agree, that was a lot of information, right? We literally went from SaaS to PaaS to IaaS. And I hope if anything now, it sort of demystifies agents a little bit, because I truly believe if you understand how they work at the IaaS level, then all of the other stuff makes sense, right? Now it should be easy to connect the dots with Azure. It should be easy to understand why Copilot Studio works the way that it does, et cetera. So with that said, we're out of time, but I will hang out and take questions because I think lunch is next. So we don't have to necessarily turn over the room. So if you want to stay and ask questions, I'm happy to answer any questions. Is that fair to say, Ange? Okay, perfect. Great, thanks. Okay, perfect. Yeah. Any questions? Yes.
I'm just curious around agents, right?
Yeah.
Everyone experimenting with agent creation. I'm sure everyone's excited to
get
their hands on development. But have you seen how companies have started managing agents? Like it's going to be similar to, I don't know, macros in the past or even in the present.
Yeah, I think the best example of that, and it makes sense that it's the first thing that people are doing, is a lot of people are starting to do agents in Copilot Studio. And it's because it's built on top of the Power Platform. You are going to pay a premium. It costs money, but in exchange for that money, you're getting that trust level. Like it's built on something that people already understand, which is Dataverse. Microsoft's making it very easy for people. One of my favorite companies and friends actually from Europe, there is a company called Rencor, RENCRR, and they actually cover the governance side of things. And AvePoint, one of the sponsors of this event, they have tools to help with governance and management as well. So it sort of reminds me of the old days with like SharePoint web parts and components where, you know, it started with Microsoft having some built-in ones, and then the community started building some, and then people realized, oh no, we need governance, right? So then other partners started. So that's sort of where we are right now. And I think the partners that are very forward-thinking, that are building their own stuff, they're doing what we're doing. They're looking like at the Microsoft agent framework, etc. So, yeah. All right, cool. I expect more questions, but I will take that as a compliment that I'm getting very good at explaining this stuff. And so with that said, thank you very much for your time. I appreciate you. Thank you.